All right, you guys, so we're going to be talking about types of reactions here, and there's 6 types of reactions that we're going to talk about. Type number 1 is called a synthesis. It's when 2 or more substances react to form one product. So you have substance A, it would react with substance B to form compound AB, where those 2 substances are together. So an example of this would be like magnesium oxide reacting with water to give you magnesium hydroxide. As you can see, the 2 reactants became one product. That's the big red flag here. You have one product for synthesis reactions. Now, decomposition is exactly like what it sounds. So for type number 2, it's a reaction where one compound breaks down into 2 or more substances. So you have your compound, let's say AB, the 2 substances are together, and it breaks down into A plus B. So for example, this would be something like sodium chloride, I'll give you the balanced example, breaks down into sodium plus chlorine. So here you have one reactant that's breaking down into 2 products. So that's your kind of big red flag here, is that you have one reaction, one reactant over here. Also, synthesis and decompositions, if you notice, are opposites of each other. All right, single displacement is when one element takes the place of another in a compound. So here you have substance A and compound BC. A is now going to be in the compound, and B is going to be kicked to the curb all by itself. So you have something that's single on each side. Here A is single, here B is single. That's why it's called single displacement. So an example of this would be silver nitrate and zinc would give you silver and zinc nitrate. And as you can see here, zinc's by itself, and silver is by itself. So that's why that is a single displacement. Then a double displacement is exactly like how it sounds. The 2 compounds exchange partners, okay? So we have AB, then we have compound CD. Everybody flip-flops partners. A is with D, and C is going to be with B. And there's a reason why I wrote CB and not BC, and it's because if you look here, positive ions switch which negative ion they are attached to. So if you remember from formula writing, positive ions go first. So positive, negative, positive, negative. The A would have to go with the D because it cannot bind with the C. And the C only can bind with the B, but you have to write the positive one first. So that is why those combine in that way. All right? So an example of this would be magnesium chloride with potassium iodide would give you magnesium iodide and potassium chloride. There's a 2 in front of that to make it balanced. So here, the magnesium and iodine went together, and the potassium and the chlorine ended up together. Everybody flip-flopped. The last 2 are called combustion and neutralization. Combustion means fire. And it's when you have a hydrocarbon that reacts with oxygen to produce carbon dioxide and water. Now, a hydrocarbon, if you remember, is a substance that only contains carbon and hydrogen. So it's some sort of carbon number with any hydrogen, makes oxygen. Oxygen is O2 because it's diatomic. Gives you water and carbon dioxide, CO2. So an example of this, and I'll do one with a really big number so you can see what kind of crazy numbers you can get for balancing equations. But C8H18 is octane, and if we're going to make this balance, you would need 50 oxygens to give you 18 waters and 16 carbon dioxide. So you have a hydrocarbon, something that's only made out of C's and H's, and oxygen gives you water and carbon dioxide. That's how you know it's a combustion reaction. Now the last one is called neutralization. The neutralization is just like the double displacement reaction. It's actually a specific type of double displacement reaction. And it's when an acid and a base make a salt and water. Now you know something is an acid if it starts with an H, is kind of a good way to know it's an acid, and a base if it ends with an OH. You got to remember that a salt is just any ionic compound. So yes, sodium chloride is table salt, but potassium sulfate, calcium nitrate, calcium chloride, beryllium fluoride, everything that's an ionic compound is still considered a salt. A salt is just another name for ionic, okay? So an example I'm going to give you here is sulfuric acid, which is H2SO4 with potassium hydroxide would give you potassium sulfate and water. So yes, it looks like a double displacement reaction because water's with the sulfate, or hydrogen's with the sulfate, excuse me, and now the hydrogen is with the OH, because water could be written as HOH actually, if you didn't know that. And there should be a 2 out front here to make it balanced. And potassium ends up with the sulfate. So it looks like a double displacement, but it's a specific type of double displacement because here is your acid, starts with an H. Here is your base. This is a salt because it's ionic. And this is your water. All right, hopefully that helps clear up these different types of reactions. Those are the 6 that you're going to need to be looking at.